Can you guys on Zoom hear me okay? Okay, cool. Here is the link to sign in. Okay. More people are joining. Okay, let me resend the link. Okay, Zoom people, I sent the sign-in link where you can scan it if that's what you want to do. Okay, so yesterday after class, I sent out a poll thing, if you guys saw it on the Remind, basically asking what you felt you need the most help with for this like section that we're going over right now. Do you guys like that? Because I like it because it helps me make my worksheets and stuff. Are you in the Remind? Okay. This is what you'll use to join the Remind, and I think I'm gonna go ahead and start doing that like once a week, so that way I can get an idea of what you guys need the most help with, what you want to go over the most, and so that way we're not like all going over stuff that everyone pretty much feels comfortable with. Because what I gathered from that poll is that you guys really want to go over oxidation numbers and redox reactions. So that's what we're going to do. Okay. I'm going to stop that share. Okay. Okay, so I want to start off with seeing how we feel about assigning oxidation numbers. Not in a chemical reaction or formula or anything like that, just in a compound. So we're going to start with H2SO4. What's the name of that compound? So not hydrogen sulfate. Not dihydrogen sulfate. So yes, it's an oxyacid. Okay. Stick behind after session. Yeah. So it's an oxyacid. So what does that tell you that this is going to end in, at least? If it's an 8, then it's an ick. So we have an ick acid. Sulfuric acid. Oh shoot, I was about to rewrite it. I'll go ahead and rewrite it. Sulfuric acid, this is sulfuric acid. Does everyone online understand how we got that? How we got the ick? and the acid and all that. Okay, if you have any questions, just send them in the chat or turn off your mic, or not turn off your mic, turn on your mic and say something, and we can stop and go over it. Okay, so I want to know the oxidation number of sulfur in this compound. Where are we going to start? What do you mean split them up? No. No, we don't have to do. We don't have to break them apart into their ions. So I want to know, here, let me write it. So I want to know the oxidation number for sulfur. So what's
4 times -2 plus 2 times 4.
Yes.
Or,
No, not quite.
or would it be S plus 2 times 1 plus 4 times 2.
Yes, equals what? What does this whole compound equal to? The oxidation number of this entire compound. Zero. Why is it zero?
Because sulfur is -2. There's no charge given in there.
Because no charge is given. If that molecule or that compound had a charge, it would list the charge for you. If there's no charge, you assume zero. It's neutral, right? Okay. So oxygen is an element that has a set oxidation number. What is it? -2. And how do we find the -2? Yeah, from the periodic table, from its placement on the periodic table. Since we have 4 oxygens, we're going to times it by -2. It's going to give us a total of -8 for that oxygen. What about hydrogen? 2 times +1 or 2 times -1? Positive. So basically what it comes down to is we have a +2 plus x plus -8 is equal to 0. Yeah, the question will ask you. Positive or -6? +6. Yeah, you can make it whatever you want. It's just +6. No, yeah. Some people write it 6+, and it's the same thing. People just sort of mix those around. Okay, how'd you guys feel about that? Good? Okay, cool. So what I have planned, just so you guys know what's coming, I want to work out the first page of the worksheet. It's all redox stuff. So I want to work through that. And then, oh shoot, my key is over here. And then I spent like 20 minutes making a Kahoot, and then I don't know what happened to it. But I found another Kahoot over oxidation stuff that I want to run through. And then the back of the worksheet, we'll come back to the worksheet. The back of it is acid base. Does that sound good? Okay, cool. So what does an oxidation number represent? We spend so much time talking about it, but what does it even mean? Mm-hmm. Loss or gain of electrons. So an oxidation number represents the number of electrons an atom gains or loses to form a chemical bond. Oh, not phone, bond. And this should sound pretty familiar because it's basically just a charge, like the ones we wrote at the top of our periodic table. Okay, so what is oxidation? If something is oxidized, what does that mean? Loss of electrons. Yes. So what's reduction? Gain of electrons. And what's the thing that acronym? Leo. Yeah. I think the part that trips most people up, at least tripped me up when I first took this class, was gaining of electrons is reduction because you're losing electrons, so it feels like you should be that like losing electrons feels like it should be reduction, but it's flipped. So if the Leo-GR doesn't work for you and that's still kind of tripping you up, think about it like you're gaining an electron, which is like a negative thing because it's a negative charge. You're gaining negatives. So you're reducing. Like if someone came up to you and was like, hey, here's negative $1,000, you were reduced. Okay. I made this and then I realized I didn't want to do this question first. So we're going to go to number 4 and then we'll go back to number 3. So in which compounds does sulfur have an oxidation state of +6? There may be more than one correct answer. So we're going to do what we just did for all of these. As long as there's no charge, like for these here, yeah, you'd equal it to -2, -2. Uh-huh. Someone on Zoom, tell me what the oxidation number for sulfur in answer choice B is. And you can just send it, not -2, but I see where that comes from. So let's go ahead and break this down. So we have SO4 -2. So that means we need to equal up to -2, right? So same person, what's the oxidation number for oxygen based on our periodic table? Or a different person, just someone on Zoom. So remember that this is going to be based off of our periodic table. Towards the beginning of the semester, when we started talking about ions, Ms. Adams had you write positive and negative numbers up at the top of your periodic table. Yes. For oxygen, it's -2. And we have 4 of those. So we multiply them and we get -8. So now we need to figure out what our x is. So we have x plus -8 equals -2. So what would have to be our x, or our oxidation number for sulfur, in order for this equation to work out? Yeah. Yes, +6. So that means that's going to be one of our answers because it has an oxidation state of +6. Okay. So here's what I want to do with these last 3. I would like one volunteer in class. Just raise your hand. To solve letter C. Okay, go ahead. Just go ahead and figure out what the oxidation number of sulfur is in that. And then could I get Elijah on Zoom to do letter D and Ashlyn on Zoom to do letter E? E feels kind of tricky just because there's a lot of numbers, so if you need help, just say something in the chat and I will do it up here. Does anyone have it yet? Okay. +4? Yep, that sounds right to me. So it's not one of our answers. In D, it's +4 as well, so that's not one of our answers either. Okay, so in the class, I just want to know, how many of you like look at E and you're like, oh my God? No? You feel pretty- Yeah. Yeah.
And then divided by 3 is. I just did it. Because then there's the 3. Because there's 3 sulfurs.
Well, yeah, but I'm just saying, like, I mean, you do that at the end because you
Yeah.
get every.
So, whew, this is a little wonky. Okay. So yeah, you would end up with a positive 12. If she asked you for this on the exam, I want you to divide by what's present. So you would,
Write down the 1 sulfur is equal to 4.
The reason I say this is because, so notice up here, like let's go with this example. In this, you have a total oxidation of -8 because we multiplied it by 4, but the oxidation number of oxygen is still -2, right? So that's why we're going to do that here. And you guys are luckier than last semester because last semester I put this one on the worksheet and then I was like, oh my gosh, I don't know what to do either. And then I figured it out. So, okay. So I'm going to go down to 5 and then go back up to 3 because number 3 is a lot of what we're doing right here. Which element is reduced and which is oxidized? So will the element that's reduced have more electrons on the reactant side or more electrons on the product side? Or on the product. The element that's reduced will have more electrons on the product side than on the reactant. So we're going to have to calculate all the oxidation numbers. Okay. So what is oxygen always? -2 plus these 3, so we're going to have -6. We need it to be equal to -2, so what's our sulfur? You can always put the X. I was just sort of skipping over that step, like writing that out. But if you want to, you can always do X plus -6 is equal to -2 and figure out what that is. It's going to be +4. What's the overall charge for oxygen here? -8. So we have -8. We want it to equal to -1. So what do we have to have here? +7. And again, if you prefer to write out that full equation all the time, if that helps you, do it. Go ahead and do it, whatever works best for you. Okay, so oxygen here is -8, and sulfur has to be +6. Here, what's manganese? You have to calculate it. So look at this, what's on the worksheet. We have Mn 2+. What's going to be the oxidation number? Well, see, so you have to, no, not that. Okay. Mn plus 2 is +2. Yes. So whenever it gives you, also on Zoom, no one in class got that either. And I know she goes really, really fast through the material. So this is something I really wanted to hit on. If you have an ion, the charge is equal to the oxidation number. So if you were given a sodium ion, what's the charge, the oxidation number of it? 1+. If it's by itself and it has a charge, that's it. Okay, So it's 2 plus. Does that concept make sense to you guys on Zoom? You can just give like a little thumbs up react. Okay, cool. So, which element is reduced? So, if an element is reduced, does it gain or lose electrons? It gains electrons. So we're going to look with something with a smaller charge on the right side, right? So manganese is reduced. And so this is another important concept I really wanted to hit on. Just because this isn't negative doesn't mean it's not reduced. It still lost 5, or it gained 5 electrons. Sorry, my bad. It still gained 5 electrons. Even though it didn't go into the negatives, gaining electrons is always reduction. So which element is oxidized? So what? Element. Sulfur.
So if it goes
Yeah, so if the charge becomes more positive, it's oxidized. If the charge becomes more negative or moves towards the negative end, that's going to be reduction.
so for example, like the oxygen, it's like this is the negative base, so like C, but combine those sides of the negative base, it lost those electrons because it's smaller than the
Oh my goodness. Yeah, no, I see what you're saying. So what I'm going to go with is because these two have the same charge. Yeah. Yeah, I see what you're saying. I get that. Okay. Kahoot. We're going to do Kahoot. So share my screen. I'm going to share like my whole screen. Oh my goodness. Oh, okay, I can move it. Okay. So my only.
Isn't chemistry the best? Chemistry is.
What
so
is
fun.
this?
I love redox reactions. Oh my god.
Okay, so my only thing is don't use your real name. Use a nickname, use a fake name,
Well,
use
if you're not part of this
an
Olympiad,
emoji
you're
as
part
long
of
as
the
it's
Precipitate.
as long as you don't put anything vulgar or inappropriate.
So funny. Paul, isn't that joke so funny?
You're good, you're good.
That was funny. Not. That was stupid in the frat pregame last night. 1K? What is this, amateur hour?
Paul, we love redox reactions, and we're gonna tell you all about it.
You change the charge
What
from the
is this?
left
Oh my goodness.
to the right. When you're oxidized, electrons out of sight. Reducing's not the same. You gain electrons in this game. Redox shows the charge is gonna change.
Doesn't reduce trading electrons, they exist as a rhythm apart you can't tear. Each half is exist as a pair, them apart you can't tear.
Four redox reactions that you
Yeah.
should know.
Okay, so just one more person.
There's synthesis, decomposition, displacement,
Okay, cool.
and combustion. Oxidation, number changes, electrons, moving places.
Okay. Can I get it now? Right, so why is it not positive 10? Because you divide it by 2, right? Because it wants to know the oxidation number for P, and we are given P2. So when you calculate, you're calculating for 2 Ps. You have to divide it by 2 to get that 1. Okay. -1. So here's something I want you to write down because it's very, very important. I'm going to go ahead and pause the share. Let me see now. Okay. So one thing I want you to write down wherever. Hydrogen can be 1 plus or 1 minus. Right? And it's all going to depend on the placement of the hydrogen. If it's at the very beginning and it's acting as a cation, it's going to be positive. But do you see how in this question it's NaH and Na is a positive 1 based on your periodic table? So you're going to have that -1 to cancel it out and make it neutral. Is everyone comfortable with that idea? It's -1 in this one because it's at the end of the compound. Yeah. So sodium is +1 and hydrogen is -1 here. Okay. Yes. Yes, if there's no charge given on the molecule you're working with, it's neutral. Okay. positive 5. So we have this O4, which is going to come out to what? Negative 8, and we have an H at the very beginning, so is it positive or negative 1? Positive 1. So we have a positive 1 and negative 8, that gives us negative 7, and we need to get it to negative 2. So how would we do that? With a positive 5. Ooh, okay. So negative 1. So it was asking for oxygen, right? What's the oxidation number of potassium? Positive. Positive what? 2? And then we have 2 of them. Okay. Okay, cool. So the, oh, what was I saying? Here, do you have a periodic table on you? Because I do not have mine. Okay, so potassium is a positive 1. And we have 2 of them. So we have a positive 2 that we're working with. We need it to be neutral. How do we turn a positive 2 into 0? Subtract 2. So now we have a negative 2, but that's our total for 2 oxygens. We only need 1 oxygen. So you divide that negative 2 by 2, and you get negative 1. So I understand this question is a bit funky because we're very tempted to look at our periodic table, and oxygen is given a negative 2 on the periodic table, right? So here's what I want you to remember. Whenever it's asking you to determine an oxidation number, even if it's something that's normally very standard, don't go off the periodic table for that one. You're going to calculate it just like we calculated sulfur and all these other ones. Positive 6. Okay, you guys are doing really well with this. Oh wow, this music is really ominous. Oh gosh, it got worse. Sorry, I didn't realize this music would be so like anxiety-inducing. +4.
Sodium's a positive one, but there's two.
Uh-huh.
Alright, so when do we divide? 'Cause I got confused on that.
So you're going to divide only when there's a subscript for that element. Little number. Like the 3 on the Wow. Okay, we just got a few more. And then we're gonna do acid base and then we'll be done. Is hydrogen +1 or -1 in this? +1. Okay, we're doing so great. So this -1, I see exactly where you're coming from, because if you look on the periodic table, that's what it is. It's a -1. So just remember that when it's asking you for that element, like totally ignore what the periodic table says about that element and just go ahead and calculate it like you would the others. What is the charge of an element in its elemental form? It's 0. An element in its elemental form is going to be 0. It's neutral. So there's only 10 seconds left, but I'm going to give this like hint left. So N2, nitrogen is a diatomic molecule, right? Ooh, evenly split.
I could not get.
That's fair. Yeah, the timing on this is a bit fast. So nitrogen is diatomic, right? It's a diatomic molecule. That's its elemental state. The nitrogen that makes us the air we breathe is N2. So since N2 is the elemental state, what's the oxidation number of N2? Huh? So here, let me. So N2 is the elemental form of nitrogen. So rewind to like a minute ago. what did I say that the oxidation number for an element in its elemental form is? 0. It's neutral. So that means this N2 here is neutral. And this is why Miss Adams kind of made a big deal about remembering the diatomic molecules, because it's going to come up in stuff like this. So because it says nitrogen, you just have to focus on where there's nitrogen. You have a 0 here. What's the oxidation number of nitrogen in this? Is H positive or negative here? Negative. We have a -3, and so N is +3. So we're going from a +3 to a 0, meaning corn nuts. Yeah, this was reduced. This was reduced. So those that were told you were wrong, you were right.
Wait, so let's say like
0.
the worst of the diet.
So there are 7 diatomic molecules, and they'll form a molecule with themselves with 2 of them. So it's just knowing that N2O2 I2 is the elemental form, and therefore the oxidation number of it is 0.
So is
Fluorine is 2. And then sodium and aluminum. I don't know about sodium. I know aluminum is 1. There's just 1 atom. Yeah, F2 is one of them. Okay. Last one. My recommendation in these is to start off with the elements that are in their elemental state on one side. So what are the 2 that are in their elemental state? I2 and H2. Yep, hydrogen. Okay. So, excuse me. So no one chose H2O, which is great because it's a compound, it's not an element, right? So then iodine is what? Zero here. And on the reactant side, what is iodine? -2 overall, because we have that coefficient in front. -1. Yeah. So, so
divide by that 2 up there. Or you use it divide by
subscript, yeah. So iodine goes from -1 to 0. So is it oxidized or reduced? Oxidized. So hydrogen. What is hydrogen here? And so my other piece of advice that I have to give you is to totally ignore the coefficients when you're doing oxidation numbers. Just pretend like they aren't there. +2 here. So the whole thing, the whole H2 is +2. Oh. So what is oxygen? -2. So what does hydrogen have to be? H2 have to be? +2, and then we divide by the subscript, excuse me. So we have a +1 for H, right? We have a +1 here, and then we go into 0. And if you were still looking at the other H, what is this H here? -1. Either one you look at, it gets reduced, right? It goes from a positive to 0 to negative, so it's hydrogen. Okay. So. Okay. So. I'm apparently really bad at estimating time. So what I'm going to do is, would you guys prefer, and on Zoom, if you could give your input as well, that would be super great. Would you prefer that I go over this acid base in a video and upload it onto my website? Or would you prefer if I just put this at the beginning of next week's session? Okay. Okay. If you would rather me go over this, like upload a video, or if I should just put it at the beginning of next session. Yeah. And then just stay behind. Okay. Okay. I'll do a video and I'll get that up as soon as possible. Okay. Are there any questions on Zoom before we end things? No? Okay. I'll see you guys in class or on Zoom tomorrow.